Okay, good morning class. So today we're starting our topic on Euclidean Geometry. This is a textbook we will be using. Okay, it's a minor action series. This textbook was supplied to you by the school. The previous topic we used a different textbook because over the years I feel that textbook is a better approach for the way I teach, whilst the geometry in this textbook is better than the platinum. Okay, it's my personal opinion. Others would differ, but we will be doing geometry from the minor action series. Okay, so I gave you a homework at this point already on geometry, and that was dealing with the revision of grade 11 circle geometry, not so? And that was on page, sorry? What page is this on? 200 and? Page 240. Geometry starts there somewhere. 242. Okay, different books is different. The textbook I have in my hand is 233. So as time carries on, they change they correct the mistakes and so on, or they take out what is unnecessary and replace certain topics with more work and so on. So we're looking at this basically chapter 8 in any textbook. Okay, it's the Euclidean Geometry section. So going through the introduction here, revision of earlier concepts, grade 8 to 11. Whatever you've learned in geometry previously remains. Okay, that angles on a straight line adds up to 180. Angles around a point adds up to 360. Vertically opposite angles are equal. Corresponding angles are very important when it comes to corresponding, alternate and co-interior. We have to state the lines that are parallel. If you don't state the lines that are parallel, definitely you're going to lose a mark for that thing. We know corresponding angles are equal, alternate angles are equal, and co-interior angles are equal to 180, also known as not complementary, supplementary. Supplementary means to say it adds up to 180. We know that angles, you get different types of triangles. You get scalene, which means to say what? All the sides are different and all the angles are different. You got isosceles. We have two sides that are equal and the opposite angles being equal. Okay? So if the two sides are equal, then the opposite angles to those sides are equal. Okay? And the converse or the reverse is true. If the two angles are equal, the sides opposite those angles are equal. Okay? So isosceles triangle, very sticky when it comes to reasoning here. There are two reasons for isosceles. We can't say isosceles triangles. It's either angles opposite equal sides, if the sides are equal, you're referring to the angles, or angles opposite equal sides. The sides are equal, which result in the angles being equal. If you use the wrong reason at the wrong point, you're going to lose the mark, okay? The reason mark. But we'll speak about that as we get there. We know about equilateral triangles. Equilateral triangles, all angles adds up to 90 degrees. Not so? Equilateral triangles. Sorry, all angles are 60 degrees. I just thought of something now. I don't know if I can change this and show you what I'm reading. Yeah. There we go. I must remember to change it back. Alright, so equilateral triangle. So we went through all of these here already. So your equilateral triangles are angles that adds up to 180, but each angle is 60 degrees. What is an equilateral triangle? All sides are equal and all the angles are equal. You got a right angle triangle, the one interior angle is going to be 90 degrees. Okay? And then we get, so we know the sum of triangles adds up to 180. Very important that the exterior angle is equal to the sum of the two interior opposite angles there. The theorem of Pythagoras can be written as the hypotenuse squared is equal to the sum of the other two sides squared. So your hypotenuse in this case is going to be AC squared is equal to AB squared plus BC squared. When you use the theorem of Pythagoras in geometry, we must state Pythagoras and you must state the angle that is 90 degrees. You all understand? Or you could have represented, if you want to calculate AB, you can say the hypotenuse squared, which is AC minus BC squared, AC squared minus BC squared. Or you want to calculate BC, will be the hypotenuse, which is AC squared minus B squared there. Okay. Then we get your congruency. There are four conditions for congruency: side, 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 side angled side, right hand hypotenuse side, and angle angled side. Did I say that one? Side, 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 side angled side, right hand hypotenuse side, and angle angled side. Okay. Those are the four cases for congruency. The one case, however, if you have two lengths, it must be the included angle. If it's not the included angle, it is not enough to conclude congruency. Okay, you guys understand it? Alright, and this is condition 2 here, and we spoke about that many times. Okay, this condition must be met. If you have two sides and an included angle, then you can use side angle side. Otherwise, it must be RHS if it's a side. It can be a hypotenuse, an angle which has to be 90 degrees, and a side. That's the only case where if you have two sides and a non-included angle. Further on, you must have, if you're going to use two sides, it must be the included angle. As you can see here, two sides and the angle that lies between the two known sides. Okay. The fourth case, congruency, we spoke about that. The midpoint theorem, what you guys did in grade 10, and the proof thereof still stands. We know that if you have the midpoints of two lengths being joined, the line being drawn will be parallel to the third side, and also in this case DE is equal to a half BC, or BC is double DE. Okay, so there's a relationship between the lengths there. Then the converse of that midpoint theorem, if you're using this case, you're going to say midpoint theorem. If you're going to use one side, or two lengths that are equal on the one side, and a set of, or a pair of parallel lines, then this is going to be the converse case of the midpoint theorem. So if the AD is equal to DB and D is parallel to DC, then we know that AE is equal to EC. Also we know that DE is going to be half BC, or BC is double DE. Okay. Properties of quadrilaterals, people, very, very important. There are four cases for a parallelogram. What are the four cases? Opposite angles are equal, opposite sides are equal, opposite sides are parallel, and diagonals bisect each other diagonals bisect each other, which means to say they cut each other in half. Okay. And then your proofs here on page 235 is nicely outlined here. In order to prove that something is a cyclic quad, not a cyclic quad, a parallelogram, there are 5 ways. That 4 that I've mentioned can be used in the reverse. The reverse of a theorem is called a converse. Okay. And there's one more to prove that something is a parallelogram. The learners always forget and very seldom used, is that if we can prove that one pair of opposite sides is parallel and that same pair is equal in length, then it's also parallelogram. Okay. But as we go through this chapter, you'll see all of this come into light. A rectangle has 6 properties, I think. No? Rectangle has 6. Opposite sides are equal. Opposite sides are parallel. Diagonals bisect at 90 degrees, and diagonals bisect each other equally. Diagonals are equal. The vertex angle is 90 degrees. And one more I'm missing. Parallel, equal, all angles is 90 degrees. Okay, so I'm counting one extra. So it's 5 properties of a rectangle. If I missed one, then that's the one I'm thinking of. A rhombus has 5 properties. Opposite sides are equal. No, all sides are equal. Opposite sides are parallel. Diagonals bisect each other. Diagonals bisect each other at 90 degrees. Diagonals bisect the vertex angle. Okay? There's only 3 shapes where the diagonals are perpendicular. The one is the rhombus, the other one square, and the other one is a diagonals are 90. These are the diagonals. One more shape where the diagonals is 90. Rectangle. No, we just passed the rectangle. There wasn't one of those there. Kite, yes. Okay. Did I mention all the properties here? So 1, 2. Yes, I think I've mentioned them all. A square has 7. The square is the what they call the ideal quadrilateral, or the perfect quadrilateral. All the properties are in this one. Okay. All sides are equal. Okay. Opposite sides are parallel. Diagonals bisect each other equally. Diagonals are equal. Diagonals bisect at 90 degrees. The diagonals bisect the vertex angles. And one more I'm missing. Sorry? Did I say the vertex angles are 90? Okay. Didn't I say? Right. So these are your 7 properties there. Trapezium, there's 1 property. What's the 1 property of the trapezoid, the trapezium? It has 1 pair of parallel lines. It's the only thing it has there. Then a kite has 5. 2 pairs of adjacent sides equal. Diagonals bisect each other at 90. One diagonal bisect the other. One diagonal bisect its vertex angles. And one pair of opposite angles are equal. Right, circle geometry. We know what a tangent is. A tangent is basically a line touching the circle at 1 point only, as you can see there. A second is a line that's cutting a circle at more than 1 place, or 2 places in this case. A diameter is a special chord. No? It's a special chord, and it's a chord that's going through the center. Okay, a chord is a line that's drawn from one point of a circle to the other. Okay, a chord and an arc divides the area of a chord and an arc. That area is known as a segment. Okay, and a sector is 2 radii and a part of a circle. It's called a sector. Okay, and there's the names there. So all of this here you guys can go through. Exactly what we spoke about. The circle geometry, our favorite. The rules are being refreshed there as well. Okay? Don't forget all the theorems, the proof theorems needs to be known for the exam as well. Not for this one, but for the June exam. Okay? All the theorems here, revision. So I gave you number 1, 2, 3, and 4 for homework. Not so. So what we're going to do is, there's not the, oh, you've got half an hour left. Okay. So what I'm going to do is every day, I think I'm going to do 1. Okay. So today I can do 2. And the proof. Alright, let's just start something. So I'm looking at the revision exercise. What page is this on? As I said, our page numbering will be now a bit screwed, okay? because of the different textbooks and all of those things. Okay, so as I said, every day we'll just do one of it. At this point you should have done all four already. Okay, this is a revision exercise and this is on page, it's going to go according to what I have here. It's 242. Okay, page 242. Am I talking too much? Yes, okay, I'll try and talk less. Right, so we're busy on the revision exercise. Okay, we are told that O is the center of two concentric circles. Big words here, no? What's concentric circles? Circles that is having the same center. Not so? You see, both circles have the center at O. You see that? AB is a chord of the larger circle. AB is a chord of the larger circle. And a tangent to the smaller circle. Okay, so a tangent, we said it's going to be a line that cuts the what's the name, 1 point only. Okay. Then, OM is joined. OM is joined. What is now OM? What will OM be? Your radius. Not so? So we got the radius and we have a tangent. So what's the relationship that's going to exist there? M1 will be what? 90 degrees. Why? Perpendicular from, no. Radius perpendicular to tangent. M2 will also be 90. So radius perpendicular to tangent there. Then we are told that if OA is 20 centimeters, OM is 12 centimeters, calculate the length of AB. So could I calculate the length of AB straight? No. What can be calculated at this point? AM. How? Pythagoras. Well, what do we need for Pythagoras? We need a 90 degrees. Is the 90 degrees on the diagram? No. So it's a rule, whenever something is not on the diagram, it must be stated. We must state it. So we need M1 to be 90. So we say M1 is equal to 90 degrees. Why? Radius perpendicular to tangent. Okay? You must write it. If you don't write that, then you use Pythagoras, you're going to lose everything. The reason for that is because you're just assuming it's 90 degrees. You understand? When it comes to mathematics and you're assuming something, it's going to be dangerous. Okay? So you must say this 90 degrees, radius perpendicular to tangent. Now it allows me to use Pythagoras. Okay? So according to Pythagoras, it's going to be 20 squared equals AM squared plus 12 squared. But you guys write 20 squared minus 12 squared is equal to AM squared. That's fine, no problem. We said you must have a reason. And what's your reason here? Pythagoras, yes, you write Pythagoras with angle M1 equals 90 degrees. Okay. So now we go AM works out to be 20 squared, which is 400 minus 12 squared, 144. Going to give you 256, the root thereof. going to give you 16. 16. Okay. Ever answer the question? But we know that AM is equal to MB. On what account is AM equal to MB? Line drawn perpendicular to chord bisects the chord. So we write perpendicular from center to chord. Not so? So we say therefore AB is equal to 32. Or you could have written 2 times 16. The same thing, no? 2 times 16, then you write 32. So it's 32 centimeters wide, perpendicular from center to chord. The theorem says this line is drawn from perpendicular from center to chord bisects the chord, which means to say cut the chord in half, which means to say AM is equal to MB. Alright, you guys got it? Just remind me tomorrow we will look at number 2. Okay. Every day we'll just do one. So we just don't get lost in with time and with all those things. Okay. So now we're looking at, let's carry on. Now we're looking at important concepts required for triangle geometry. So now we're going to, last year our concentration was, we concentrated on circle geometry. Okay? Here we're introducing now triangles into geometry. Okay? The area of a triangle, how do we normally calculate the area of a triangle? It's half base times perpendicular height. Or the height must be relative to the base. Okay. So if we look at number 1, okay, this was your base and there's your height. Can you see that? It's a relative, the height is relative to the base. Okay, it's 90 degrees to the base. If you look at the second triangle drawn, there's your base and that's your height. Your perpendicular height. Not so. There's your base, perpendicular height. There's your base and there's your perpendicular height. So the height is relative to the base. Okay. You guys understand that? Okay. And we see it in this we are told here in all the cases the area of the triangle can be calculated by using the formula. Area of triangle ABC is going to be half a base times your height. In B, we are told that two triangles which share a common vertex has a common height. Okay, let's look at this, draw that out. If we have a triangle here as drawn, you see this, or we can just use this here, okay. See this perpendicular height here. However, if you draw the triangle going this way, okay, as they have there, so you've got A, B, C, D. You see this triangle here. What is the base of triangle ACD? CD. And what is perpendicular height? Is the H again. Can you see that, people? So again, we are reading here two triangles which share the common vertex. This is the vertex they're talking about. Okay? Common vertex has a common height. It's very important. We're going to use that extensively. Okay? And it's given there in another form. You can see that it's still having a common height. What would the common vertex be in the second diagram? What would the common vertex be? It would be E, yes, absolutely. And there's your height. Okay? We carry on. Also very important concept to understand. Triangles with equal or common bases lying between two parallel lines has the same area. Okay, so let's draw that out quickly. we have two parallel lines. You guys know what parallel lines are, eh? The triangles with equal or common bases. So let's say that is your base, okay? And that's your base. So if this is a base of 2 and that's a base of 2. Sorry, man. Hello? Yes? You can call me in 25 minutes. Okay, sorry about that. And you see, it has the same base here. Let's say the distance between these parallel lines are 4. And you got triangle ABC here, DEF. And they ask you to work out the area of triangle ABC. So how do you calculate the area of triangle? So half base, which is 2, and the height, which is going to be 4. Because if you're taking the distance between the two parallel lines, okay, then this distance of 4 will be evident there, anywhere along that, or between those two parallel lines. Can you see that, people? This is also known as your perpendicular height. Do you guys understand? So, to calculate the area of this is going to be half, 2 times 4. The other triangle, the area of triangle EDF, will also be half. What will this base here be? 2. And what will this perpendicular height be? Also 4. Why? Because it's lying between the same parallel lines. Can you see that, people? So if we take it and see what they have, they basically say that triangles with equal or common bases. Here you will see a common base, or the base is the same base. Can you see that, people? There's the same base here, existing in triangle DBC. What you notice? It has the same height. Can you see that, people? Same height. So if it has the same base and the same height, what will then be the same? The areas will be the same. And that's what they're highlighting to us here. Triangles with equal or common bases lying between parallel lines has the same area as illustrated. Okay, so here they're just telling you that the areas are the same. If we use this rule, we say, the reason here would be, I'll probably see it later, that it will be triangles between parallel lines, equal bases between parallel lines. I think I'm shooting something. Okay, but we will get it now. It will be somewhere. Okay, ratios. We've done a lot of ratio and proportion in grade 8 and 9. The ratio and proportion we've done in grade 8 and 9 still applies. Okay. You can read through that if you have time. Cross multiplication techniques. Cross multiplication is useful when working with ratios. Consider, for example, the ratio 3 over 2 is equal to 6 over 4. You all agree that 3 over 2 is equal to 6 over 4. Not so? So if you take that ratio into account, 3 over 2, so if I cross multiply, what would that be? 3 times 4 is equal to 6 times 2. Check if that's correct. 3 times 4 is 12. 6 times 2 is 12. So what I can do is, if that was A over B is equal to C over D, then the next ratio could have been AB is also equal to BC. That's the rule I just used now. Not so? Right. Then, we say, okay, let's flip this around. Remember, we do on one side, must do on the other side. So that's 2 over 3 is equal to 4 over 6. 2 goes into 2, 4 twice. So is that the same? Yes. So which means to say A over B is equal to C over D can also be written as B over A is equal to D over C. You will understand. Right. Let's see what if we interchange those two. It would have been 4 over 2 is equal to, and then we must interchange. So it will be 6 over 3. Not so. I'm just interchanging those two. 4 over 2 is 2, 6 over 3 is 2. So is it true still? Yes. So if I interchange these two, then I got d over b is equal to c over d over b. I'm interchanging these two, no? So it will be d over b is equal to c over a. And of course we can go the other way. Interchange those two. So it will be 4 over 2 is equal to 6 over 3, which is 2 over 2. Still, not so. So I'm interchanging this here. So it's a over c is equal to b over d. Okay. Spoke about multiplying. Let's see here. If I only take the 4 up, it will be 3 times 4 over 2 is equal to 6. 3 times 4 is 12. 12 divided by 2 is 6. So which means to say I can just take that d up. So it's AD over B is equal to C. I could have just taken the B up. It's going to be A is equal to BC over D. Not so. I could have taken the A down. Then it's 1 over B equals C over BD. And so on and so on and so on. There's a lot of combinations for this. And all is true. Okay? But later on, we'll see how we will apply that as well. In general, we spoke about that now, but that's the thing. If you're a girl that wants to write all of the stuff down and all of these things, no problem. You can write it, it's all on page 245. Okay? But we will be applying this so often that you know the ratios. Okay? Because this is a lot of marks in your exam. Okay? Proportionality theorem, that's where we're at. Take this down, proportionality theorem. For homework, I want you guys to do the investigation. It's on page 246. It's labeled investigation 1. Okay, normally I spend time and do it in class, but because we spent a lot of time on sequence and series this year, normally I don't spend so long on sequence and series. It's 246. Don't write in the book, but just use your ruler and write your findings down. We'll talk about that tomorrow. Okay? It will be obvious because I'm going to speak about certain things now. Okay? But do it. It's a nice investigation. Normally I do this in class as indicated, but I've spent a lot of time on sequence and series. Okay? Normally the grade 12s are so many questions. Okay, although you guys don't really talk to me, but you guys had some interesting questions compared to the others. Okay, I didn't mean to cut that. Let's check, undo. Proportionality theorem. Your exam will be set up until this section as well. So you're writing on analytical sequence and series. That's about 32 marks, and you got 18 marks on this work. Okay. Cycle test on the 25th, on the 15th. Okay. And it's set already, so that's why I need to get through this. Right, theorem 1. This theorem you need to know. It's examinable. It's worth 6 marks. Right, I see you guys are sitting forward now. Alright, here we go. I'll send you the link to a video on all the theorems, okay? All the circle geometry theorems that I've sent you last year. I sent you the link to that video, no? With all the theorems in. Now the last 2 theorems One is the proportionality theorem, and the other one is the similarity theorem. This one is coming in. Okay, so you need to know the theorem. Right, and as I said, it's worth 6 marks. Okay, so they are ready. I'm giving you 12 marks in the exam. Okay, and 12 is a lot. 12%, sorry. 6 marks, 12%. So don't come here with less than 12% in your first exam. You're going to be very upset. So 12 is a cutoff point. No? You're not supposed to say no, yes. Say no, we're going to get more than 12. So now you're saying yes, like 12 is okay. People, here we go. The theorem says, a line drawn parallel to one side of the triangle cuts the other two sides so as to divide them in the same proportion. Let me just check. Do I have it in the right place? Yes. So where do we start? In all Euclidean geometry proofs, in all of the proofs, there's a construction that takes place. Okay? You'll always note there's a construction that takes place. Alright? So we are told that the line will parallel to one side of the triangle, cut the other two sides so as to divide them into the same proportion. We are given that BE is parallel to BC. You are required to prove that AD over DB is equal to AE over EC. Okay. Now I know some people, some teachers or whatever, they prefer to teach the theorem first, the application, and then the proof. Okay. I just find this more logical to do the theorem first and then the proof. Okay. I mean the theorem first and then application. But if they get it, somebody explain it the other way, there's no problem with it. It's just to do with what they prefer. Okay. So we start off with a construction. Okay, this normally is going to go at the bottom here. Okay. But because I want to keep the diagram in focus, I'm going to write here on the side. Is it okay? Is it okay? So we started with a construction. So you construct. You're going to construct line DC. Okay? No. You're going to construct perpendicular height. Let's start. Let's call that perpendicular height. So you're going to construct from D, from vertex D. You're going to draw a perpendicular height to A, relative to A. Okay? Then, from E, you're going to draw another perpendicular height, and it's called this K. From D, we draw K perpendicular to AD, which is this line. Okay. Then we join. We join DE and form line DE, and same with, you'll join line B. So this has got a lot of construction in it. Okay. So firstly, let's just shouldn't take too long.
Your attention, please. Ross House to meet in the prefect. Kenyon House to meet in the hall. Grey House to meet in front of school in the parking bay area. And Commander Mojave can report it.
Okay. So the proof. Okay. I'm going to go a bit quick through it so that you can still have a break. Very importantly here, okay, we were going to try in the back of your mind to get that part out first. Okay? So we say, if you're looking at AD, so that's that line, and BD. So what we're going to do is we're going to work out the area of triangle AED. Can you see that? Yeah, let's change my color here. No? So your area of triangle ADE. Okay, that's what I'm looking at. How do you calculate the area of ADE? It will be of base. What's my base? AD. And what's the perpendicular height for this triangle? K, not so. Times K. Now you see I need to pick this up here. So I'm going to use that triangle. Make sure you're using DE. So that's going to be the link between the two triangles. You'll see now how it works. Okay. So that's going to be triangle, the area of triangle DEB. How do you work out the area of this triangle? It will be half. What's the base? BD. And the perpendicular height. What's the perpendicular height for this triangle? So also okay. You guys understand? That's with the obtuse angle there. So it's going to be K. So what do you notice here? The halves cancel. The K's cancel. So what am I left with? AD over BD. You see that, people? So if you look at AE, so it's AE and AC. So it's the other side now. Okay? Alright. Sorry about that. Okay. So if you go to the other side, so we're going to say it's going to be the area of triangle AED, which is this triangle here, over the area of DEC. You guys are millionaires, no? Don't forget to buy me a notebook, no? Nice Apple computer. It's faster. Right, over the area of triangle, so ADE, over the area of triangle DEC. Alright, so it's going to be half the base AE, and its perpendicular height is going to be H over. For this triangle DEC, it's going to be half. My base is going to be EC, and the perpendicular is going to be H. So what happens? Halves cancels, H's cancel. So it leaves you with AE over EC. So what you notice here is that we have that and we have that now. The only thing is we need to link these two together. Not so. Need to link this together. So what we notice at this point is that on top I had triangle ADE, and on top I have triangle AED. What do you notice about that? The same. Not so? Because ADE is that triangle and AED is the same triangle. So those two is the same triangle. So if I can prove that the denominators triangles are the same, I've done the job. Not so? Let's look at AEB. Sorry, DEB. DEB. And this one is DEC. DEC. What do you notice here, people? What is the same in these two triangles? There's a same base, and they're between two parallel lines. And what was the theorem we said earlier on? If they lie between two parallel lines and a common base or equal base, then the areas of the two triangles are the same. So we're going to write that now down. So we got the numerators the same, so the denominators we're going to equate now. So we just go and say that the area of triangle DEB is equal to the area of triangle DEC. People, there's a link between the two. There's a very, very important link here. So at this point we already have 1, 2, 3 marks. Okay. Having this link here with reason is another mark. And the reason I don't want to get it wrong, it is going to be equal base. I will check now if I'm right. Equal base, and my base is DE, lying between two parallel lines. Okay, I think as I said, I'm missing something here. Same base, same height, that's what I'm missing. Equal base, same height and equal, same base and height between two parallel lines. That must be said like that, okay? So the area of triangle DEB is equal to the area of triangle DEC. It's equal base DE and height between two parallel lines. Another mark. Okay? Sometimes they give you 1 mark there, 1 mark here. Okay? But I give 1 mark for both. Okay? Now what we do? If that is the same and this is the same, this area of that has to be the same as the area of that. Not so? Alright, so let's write that down. So you say therefore the area of triangle ADE over the area of triangle DEB is equal to the area of triangle AED over the area of triangle DEC. But what is the area of triangle ADE? The area is AD over BD. Not so? What is the area of triangle AED over DEC? The same as AE over EC. And there we have just proven that. Okay, I'll give you the 1 mark here, 1 mark there. So how many marks? 1, 2, 3, 4, 5 marks. So yes, there is 2 marks here. 6. Okay. If I'm you people, I'll do this a few times. Make that your homework. Definite question in your cycle test. Okay. So do it again. Oh, you guys understand? Okay, let's take your word for that. People, enjoy the rest of your day. You guys have enough homework, no? But also prepare for the cycle test, no? No class on Friday. Just tell the guys, that the other girls that comes on Friday, that there's no class, okay?